Okay. Well, good afternoon, everyone. My name is Tim Garner. I'm a technical marketing engineer here at Cisco, and I'm going to be representing the Tetration Analytics team today. I'm really excited to talk to you all about Tetration, and we're going to split this into two sessions, as we usually do. This session is going to be focusing on a brief refresher of the platform itself. There's a few faces I recognize from meeting you previously in Berlin, but there's some other folks who I haven't seen yet, so I want to make sure that everyone gets up to speed with what Tetration is, what we're doing, and how will the different components fit together. After that, I'm going to introduce you to some of our new features that we're shipping in the next release, and talk about some different ways that we can bring even more data into Tetration. So without further ado, let me get down to, well, why are we talking Tetration today? Well, Tetration comes from the NCME business unit inside Cisco, the same team responsible for the Nexus 9000 switches and ACI as well. And we've deployed a huge amount of data centers with our customers together. And based on that learning, we actually picked up that there was quite a few things that we saw over and over again for every single customer. And number one on that list was that they were having a real hard time actually securing their data centers. And there's a number of different reasons why they were running into these problems. One of the early reasons that we picked up on was actually the explosion of the amount of traffic that they had to monitor to understand what was happening in their data center to begin to secure it. Now, there's lots of statistics out there, but one of the ones that you can pick up, for example, is that a couple of years ago, it used to be that the majority of the traffic in the data center was north to south. That was kind of easy because you could say, well, I'm going to put a tap or a span in my core or aggregation layer, and I'll get good visibility into most of the traffic in my data center. Now, as we know, that's pretty much shifted on its head right now, so that the majority of the traffic in the data center is east to west. Applications are sending much more data to each other before they send a final response to the end user. What that means is those traditional tools for getting visibility in the network are falling short because our customers don't have knowledge of every single flow in their data center. So that's one problem that Tetration is helping to solve with our customers. Now, on top of the data that we're trying to collect, there's a few more things that are pushing us towards this direction. Number one is actually the complexity of the data center. We all have dealt with very complex data center environments where trying to unpick how every single component of an application interacts with each other becomes a nightmare. Making changes, making upgrades, migrating applications, changing to different infrastructure. If you don't understand the complexity of the application, you're basically bound for a very bad day when you try to make any change in that data center environment. Especially as more of our customers move to a more DevOps style way of deploying their applications. What used to maybe be an application update every month or every quarter can be pushed right down to deploying code every time there's a new commit. What we found is that a lot of network infrastructures and a lot of security infrastructure is not designed to keep up with the change of the applications. So you end up with different teams inside the customer's environment at loggerheads with each other, where no one can agree to actually how they're going to solve this problem together. And one final thing that we noticed as well is that while being from the NCME business unit, I would love every single customer is deploying Nexus 9000s and is going to use ACI on top of it. The reality is that most of our customers have a very complex network environment that is made up of lots of different types of infrastructure. Some of our customers have a 7K, 5K, 2K network. Some of them have Arista switches and Cisco switches. Some of our customers are nearly primarily based in the cloud. How do they find one common layer to enforce policy across all of these different environments? I don't want to spend my day just translating policy between AWS onto my ACI fabric, onto what I have inside my VMware vCenter environment. This is a problem that we found is pretty much across the board what our customers are facing. Okay, so that's what the problem is. Let's get down to how we're solving this. So, Tetration Analytics we launched in June last year. And really when we first launched Tetration, it was mostly a recommendation engine. It didn't take any direct action in the customer's network. So starting in the top right-hand side here, what we gave them first was visibility into every single packet in their environment. Now I'll discuss how we capture those packets, but what we're doing is looking at metadata. We're pulling information from every single header and streaming that to Tetration. Tetration can pull in around 2 million events per second, and we can store up to about 150 billion flow observations inside one Tetration cluster. That gives our customers on average around 4 to 6 months worth of data inside one appliance that they can jump back to at any point in time.
Now there's multiple tetration buys you can do, big rack and smaller.
Yep.
Are those numbers true for either side, or?
So the amount of events per second and the amount of stored events is smaller for the lower version.
Yeah.
But the lower version, we only support a certain amount of sensors. So in terms of the actual absolute values that you get, or the relative values that you get, you still get 4 to 6 months in the smaller rack. You just can only monitor up to 2,000 agents in one go. So having a huge database of all of our flows is pretty interesting, but I mean, that's not really the end of what Tetration does. What we do is we take that flow information and we replay it, or I should say we push it through our behavior-driven machine learning algorithms. And what we do there is build an application dependency map. Who should be grouped together? Which endpoints exhibit similar behavior on the network? Which endpoints run similar applications? Which endpoints talk to similar neighbors? We generate these profiles and then we work out what the security policies should be in between these different groups. In essence, we give customers their whitelist segmentation policy for their data center. And it's done in a zero-knowledge way where you do not need to tell Tetration anything. You don't have to say, this is my web tier, this is my database tier. It infers that based on the network and process information that we collect. And I'll show you that live later, and I'll also talk through the type of information that we collect inside Tetration. Now, the application policy, you can take that straight out of Tetration in open formats, JSON, XML, or YAML. But what a lot of customers want to do before they actually take that policy and enforce it somewhere is understand, well, what's the effect of putting this policy in my network? If I turn whitelisting on, am I going to break applications? Most customers are absolutely terrified of that particular problem. In fact, we've seen it over and over again with deployments where they've done it and they've had to roll back from whitelisting because they didn't understand the policies correctly. It's actually really easy to implement whitelisting. It's actually, the hard part is understanding what your whitelist is to begin with. Now, one of the things that we can do inside Tetration is run simulations. Remember that number, that 150 billion flow records? What we can do is take your proposed whitelist policy that we've learnt and replay those historical flows through the new policy. Based on that, I can say, if you had turned whitelisting on 6 months ago, yeah, this packet would have been dropped, or this packet would have been allowed in your network, and relate that back to the application itself. It helps our customers make changes in their network with much more confidence as to what that change is going to do, and it helps them migrate to new network infrastructures without the fear that they're going to break the applications that the business relies on.
So Tetration obviously has full knowledge of the topology of your network then as well.
So Tetration is today not looking directly at the physical topology of how packets get from A to B. We're looking more at the logical policy. My web tier talks to my app tier talks to my database tier. Now, if that goes through a spine leaf fabric or whether my database is up in AWS, that's not really Tetration's goal. Our goal is just to understand that these are the segments and these are the rules and policies that should be in between them.
And so the whitelisting would then happen on either end of the conversation, more out at the hosts rather than in the network fabric itself.
So we actually have a number of different ways that we can do the enforcement, and what I'll show you later today is the host-based enforcement. That's the native integration from Tetration. But we can take the policy out and we can also put it into the network. Or we can offer customers a way to do 2 levels of segmentation, maybe some coarse-grained policy in their network and fine-grained policy at the host as well. So it's really down to what their appetite is for where they put their segmentation and what makes sense for their use case.
But where are you defining policy? If you had a Cisco network with ACI, are you defining policy in 2 places? Or are you defining policy in ACI and importing that here?
You define the policy inside Tetration and import it into ACI. If you're using Tetration, Tetration will become the master controller of all policy, whether that's in the cloud or whether that's on your on-prem environment.
Got it. Cool.
So what if my point of truth is in the cloud, AWS? Can I have AWS AM policies being the source for Tetration policy framework?
So in an environment like AWS, we put out agents to learn the policies based on the flows that we see inside AWS. That being said, you could import into Tetration a version of your security groups and security rules that you may already have inside AWS.
You don't need to learn them, you can query them. They're available through an API.
So if you already have the policies, then you can query them. But a lot of the problems that our customers have is that they don't know what those policies should be inside AWS to begin with. Now, there's lots of different ways. You can certainly go to the AWS API, pull out the existing security groups and rules, and put them inside Tetration. Tetration could then put that down to your host and then deploy it as a host-based segmentation as well. So you get two layers. You get AWS's level of protection and your own overlay on top, which is basically unified between your on-prem and cloud environment. So once you've taken your policy and you enforce it somewhere, the next thing that we have is the ability to monitor every single packet for compliance. We know what the whitelist should be. We know who should be talking to whom. And we also know who shouldn't be talking to whom as well. So when we see packets flow, we compare them against that whitelist. And if there's some kind of deviation, we make that visible to the user, and we also send out alerts via Kafka as well. So what this helps customers do is really get right down to the problem, rather than looking at the haystack where the majority of the traffic is. And I'll give you some more detail about what we do in our policy compliance.
What all data are you pulling off the wire? Is this just like NetFlow records, or much deeper than that?
So Tetration has its own specific telemetry protocol, which is deeper than NetFlow. We collect details about every single packet. Now, what we send is not the complete packet header. We send metadata about each packet header. But it allows Tetration to have visibility into everything, right down to, for example, the TCP flags or the window size. Now, what I'm going to talk to you in a few minutes about also is some alternative ways of capturing source data if they cannot put the sensors in the environment as well, because customers have a lot of different restrictions and they have not always the ability to put our sensor everywhere. So we've expanded that.
What's the ratio between the raw data that goes over the network versus the data that Tetration reports in your proprietary protocol?
So we see on average around 1% to 2% extra overhead.
Okay.
Cool. That's a simple answer there.
Yeah. So on 100 gig, it's 2 gig.
Yeah, and that's really 2 gig is like the worst case scenario. Most production environments, we're talking about 1% extra overhead. Now, this is what we first shipped Tetration with, which was effectively recommendation. But the next logical part, and we've already touched on this, is to take the policy from Tetration and push it down to our agents to enforce the policy at the edges inside the host, using the native firewall of the host, IP tables and IP sets on Linux, and Windows Advanced Firewall on the Windows side. You can put that policy wherever that VM lands, so wherever that endpoint lands, if it's in AWS, Azure, or on-prem.
So till now, you could create the policy, and you could observe, and you could say, oops, I think this is violating the policy, but you couldn't do anything about it. And now you can actually install filters.
Yep.
Okay.
We can install the filters prior to seeing that behavioral non-compliance, and also reactively change filters on the hosts as well when we do see something that shouldn't be happening on the network. So you get both sides of the house. Okay, so how does this work at an architectural level? Well, we have 3 main components: data collection, the analytics engine itself, and different ways of accessing that data. So I've touched on this already. There's 2 main sensor types that we can deploy inside Tetration. The first and primary sensor type is a software agent. So this is a really small agent that sits inside the workloads themselves. It looks at every single packet going in and out of that host, and it generates metadata from the headers. It also pairs the flow information with the process or the socket that generated or received that flow as well. So now we can say, well, we saw this flow on the network, but it came from Apache, or it came from Nginx, or it came from MySQL. So when we're doing our application dependency map, it's not just based on pure flow data, but it's also based on the application or the process that generated that flow. A lot of our customers are primarily just deploying the software agent because it can be deployed in any environment. You don't need to take all of your data center switches and change them for 9Ks to get started with Tetration. You can just put the software agent in and get all of the visibility, all of the application dependency mapping, all of that enforcement.
So may you wish to deploy it on AWS, how would it look like? Additional VM, additional container? What is it?
No, so if it's deploying on AWS, you simply just slide it into your EC2 instances. So you could bake an AMI with the Tetration agent pre-installed, or you can do it at runtime, let's say via Ansible.
Okay.
Now, the embedded network sensors, this is something that you can add as a complement to the software agents as well. So the Nexus 9000 switches, any switch with -X in it, has the flow cache module built into the ASIC. And as the packets pass through that ASIC, we glean metadata from the headers, We generate telemetry and we stream that back to Tetration. Because everything happens in hardware, including the generation of the telemetry packets, it has zero impact on that switch to turn it on even line rate on the 100 gig switches.
Now you said any switch with an X in the name. Is that across the entire product line, or are we just talking 9000s?
Specifically Nexus 9000s.
Okay.
Yeah.
Just double checking.
I know there's a lot of 9000 switches in Cisco right now. So yeah, you can use these two in either or combination with each other. Some customers just using the hardware sensor, some customers just using the software sensor. When you have two, what you have is 2 points of reference. It gives you the ability to do extra analytics. My software agent reported 10 packets. My hardware sensor reported 20 packets for the same flow. What could that mean? Potentially that there's a rootkit on that particular endpoint that's hiding some of the traffic from the operating system itself. The network sensor can also give us more information about the topology of the network and also help us understand if packets are being dropped inside that switch, why they're being dropped. So it's an extra complement with more data, but it's not a necessity to deploy Tetration to have Nexus 9000 switches. Now,
is that just EXFX, or is it PXs like on the old 93 side? It's just EXFX,
just
right?
EX and FX, yeah. Now, alongside the data that we capture from the software sensor and the hardware sensor, we also bring in metadata from other sources. So any device in the data center or in the cloud that does something to terminate a flow and generate a new flow. Load balancers, firewalls, proxies, anything like that, you can bring that in metadata, and that helps Tetration understand more about how flows are connected inside your data center. We natively support F5, Citrix, ACE, and HA proxy, where you can just copy and paste the configuration. Or we support open JSON schemas as well. So if you use a load balancer that we don't have vendor integration with, then you can just simply send it in a JSON format to us. We also have some other interesting third-party metadata sources, which I'm going to talk to you about in a minute, which helps get more identity about the workloads in your environment. Now, the cluster itself, we touched on this today already. There is the larger rack unit, and then there is also the smaller 8-rack unit appliance. And we have a virtual appliance that can be installed in AWS as well. So customers have different ways of consuming the product. Feature-wise, they have the same parity between them. It's purely just who you want to buy compute from and what scale you need to achieve with the amount of agents that you're monitoring. It is an appliance in the way that you do not need to know anything about big data. You just simply roll it into your data center, connect the power cables, connect the network cables, and configure it through the web UI. If anything goes wrong with the underlying software stack, it is completely supported by Cisco TAC. You just simply pick up the phone, and they will be able to remediate any problem in the cluster. So you don't need to buy a very expensive big data scientist to run Tetration for you in your customer environment. Now, accessing the data, a couple of different methods to access the data. First and foremost, you can get it through the web UI, and we'll go do that in the demonstrations later. But what we also have is a couple of different programmatic ways. Number one, as you would expect, is a full-featured REST API. REST API can do two main jobs. Number one, operate and manage the cluster. Adding users, removing users, creating roles, creating new groups, onboarding tenants. Those kind of things can be done through the REST API. And also pulling information out about applications, enforcement status, flow data. All of that comes through the API as well. And we have clients in Python, JavaScript, and Go as well. Now, event notification is how we get data out from Tetration when we discover some kind of behavioral anomaly. So event notification really is just a fancy marketing name for pushing to a Kafka broker. The customer provides us one or more Kafka brokers, and then they can consume from that into their different platforms. Let's say they want to push it into Splunk, for example. The final one on the slide here is Tetration Apps. Tetration Apps lets you have access to the underlying data that's stored on the Tetration cluster. So here you can write Python or Scala code that is run on the pipelines inside Tetration. So you have access to about 160 terabytes worth of flow data that you can process inside the platform. So you don't have to query the API for millions or billions of records, you just process it right there. They can be run as jobs every minute, every 5 minutes. They can roll up reports, send out messages via Kafka, pull in data from other APIs. the system is basically completely extensible to your own use cases. There is nothing that we don't stop you getting access to. Now, I promised that there will be a few more ways that we can bring data into Tetration. So, one of the ones that we've been speaking to customers a lot about is bringing in SPAN data, or specifically bringing in ERSPAN data into Tetration. Let's take a customer that can't install the software sensor. They can't put Nexus 9000 switches in today, but they want to get per packet telemetry. They can use their existing switches to send ERSPAN to a specific Tetration VM that you deploy in your virtualized environment. That VM soaks the ERSPAN traffic and generates Tetration telemetry from it. It's horizontally scalable, so you can deploy one VM, deploy two VMs. As you generate more ERSPAN traffic, you just scale out the amount of VMs that you use to sync that ERSPAN traffic. It gets all of that same per packet metadata. The only things that you lose is that you don't get any process level information and you don't get any information about what happened inside the switch. But it's still fantastic for getting visibility and for understanding how the applications interact with each other.
How much data can a VM ingest?
So by default, the VM has 4 VNICs. Let me just let this slide build. So the VM has 4 VNICs, 10 gig VNICs. We bind a software sensor to each 4 of those VNICs, and we don't set any limit on the amount of CPU that the software sensor can use. So we can, in one VM, soak up to 40 gig worth of traffic into it. Then you just continue to scale it out as you see fit for your environment.
So 10 gig per core?
Yeah, basically.
There's no reason you wouldn't use a visibility fabric to do this as well. I mean, why ERSPAN if you have a visibility fabric, just pump the data into that VM and then have it relay it back to Tetration?
When you say a visibility fabric?
Oh, something like what a Gigamon would do.
Yeah, in fact, that's exactly what we're doing with a particular customer right now, where they're using Gigamon to bring all the traffic together and then convert it into ERSPAN and send that to Tetration to generate the telemetry. A lot of
banks... You still need ERSPAN in that situation?
In this situation, yes, you need ERSPAN because we specifically use the ERSPAN header to understand that this is not traffic destined for the VM, but it's traffic that's destined for being turned into Tetration telemetry. So we just take the ERSPAN header off and process it like normal traffic at that point.
You need to know it's a different type of traffic.
Yeah.
Yeah. Now, similarly to the ERSPAN way of getting data, what we've also developed is the capability to bring NetFlow into Tetration as well. Now, we spoke about NetFlow before, and we always talked about how NetFlow is fantastic for certain use cases. It's not great for every single job in the data center, but for getting a good understanding of who speaks to whom and basic application dependency mapping, we can help our customers out by bringing NetFlow into Tetration as well. Now, it's essentially the same kind of model as the SPAN setup, where you generate NetFlow from the devices in your network, and you have to destine that NetFlow to a specific Tetration VM, which is running a software sensor that converts NetFlow records into Tetration telemetry. Obviously, NetFlow is not as detailed as we could get from the ERSPAN sensor because we don't have information about every single packet inside NetFlow. We just have the conversational information. What this really does, though, for our customers is basically round out the complete visibility picture. There's very little scenarios right now where I can't imagine being able to get data inside of Tetration at this point. So, where do we go from there? So we have all of the telemetry data about the packets and the processes. What's nice now is to bring more identity into Tetration. What is identity? Well, identity means, am I production? Or I live inside AWS, or I have this particular security group from campus applied to me. You can see some of the different vendors that we're working with on the left-hand side there to stream data into our identity repository. So for example, vCenter, we can bring in VM names and VM tags, or we can go up to AWS and bring in your EC2 instance names. One particular example here is being able to use ICE. So as a campus user authenticates with ICE, ICE then sends via PX grid some notification to Tetration that this IP address right now is owned by user Stephen, and user Stephen in the campus environment has SGT20. So we can extend campus identity into Tetration. And you can use that for beginning to write whitelist policies. You can say, you know, if it's a doctor, then they can access patient records, but they can't access any of the employee data. So we can bring in identity from a lot of different places, but ICE is one of the ones that I think I wanted to highlight because this is something a lot of our Cisco customers are deploying in their campus networks, and the integration between those two is a pretty logical way to go.
Can you use external database such as Radius or BCRF?
Yeah, so this is bringing identity about flows and endpoints, but for authentication and authorization into the Tetration cluster, we can use LDAP, Kerberos, and Active Directory. But if you had an identity database for authenticating your campus users, you could write a connector to take those authentication logs and stream them into Tetration. So the repository that I'm talking about here, the identity repository, you have access to that via the open API in Tetration. So you can stream in, hey, this user just authenticated via Radius, this is the IP address they have right now. Now, the open API that we have, we talked about this very briefly already in that there's the REST API, there is the event notification via Kafka, and there are Tetration apps which run on the cluster. What we've enhanced in the next release of Tetration is what we actually do with the analytical data that we pull out. Hey, we've seen something interesting, we need to tell you about it. But what we're starting to do is tell you about more different interesting patterns in your data center. So here, for example, every single minute telling you about every packet that is exhibiting non-compliant behavior. What about if someone is relying on the host agent to do enforcement? What you want to know is, hey, did someone try and mess up the firewall rules on that agent? Or did they disable the firewall? Or what did the policy look like when I just pushed out some new policy to that agent? These can be subscribed to and sent out via the event notification stream. Similarly, we can set up threshold-based notifications. So this is talking about when I have different pieces of logical policy, how can I assure that my intent is being captured? So let's say that you have a free-tier application, a web app, database app. Based on what we've learned in Tetration, you can begin to write different thresholds that we will then notify you. Tell me when my web tier is actually allowing me to connect to my database tier. Or tell me when my app tier doesn't go through the load balancer. Or tell me if I actually have screwed up my policy and my web tier can't talk to my app tier. You set these notifications up and you can decide how far or how close or how many intermediaries that you want to go between. Tetration does the work of monitoring and notifying you when we see these kind of compliance deviations.
You set here topology unaware. How would you know whether you are more than one hop or more than 5 hops aware?
In this case, I'm talking about segmentation policy. Is my database segment close enough to my web segment that they could actually speak to each other when it comes to a policy?
Not close enough physically, but in terms of segmentation.
Yes, correct.
You've got custom rules on that slide. Is that the actual nomenclature that you'd be using to write, or is that just kind of a high-level example?
So I can actually show you in the demonstration, but it basically looks like this. These are the ways that you write the rules. You can fill in the blanks as to who do I go between, and you can keep adding more, how many hops, or how minimum amount of hops, how many hops. You literally write it like this in the Tetration UI. It also sets a lot of these up automatically for you as well. So based on what we've learned, it generates a predefined set of rules, and then you can add your own custom rules on top as you see fit. Now, one of the next huge things that we're bringing to the table is multi-tenancy inside Tetration. So a lot of our customers, they're talking about, could I buy a Tetration appliance and essentially resell it inside my enterprise to different business units? Previously, that was not possible because we had a level of multi-tenancy but not complete isolation between every single tenant inside Tetration. Now, when you deploy a tenant inside Tetration, those tenants are completely isolated from each other. They have their own agents, they have their own flows, they have their own applications, they have their own policies. So this allows customers to do whatever they want, whether they want to resell Tetration inside their environment.
You're not talking about deploying multi-tenancy across the network. You're talking about breaking up a Tetration installation into different tenants that are using the platform.
Exactly, just like that. And for authentication into that platform, we touched on it earlier, being able to use Active Directory, bringing roles from Active Directory directly into Tetration to map those different groups. We have full RBAC throughout the entire platform. So I can say you can only see one flow from this IP address, or you can see these flows and you can edit this application, but you can't enforce that application. Everything is incredibly configurable right down to the last IP address. So the final thing I want to touch on right now is that we've been launched since June as of last year, and since then our partner ecosystem has continued to grow. You can see that there's a number of different partners that we are working with right now, and they provide different bits of information to Tetration. Some load balancer information, some bringing in seams like Splunk so that we can send data to them or receive data from them as well. We expect this list just to grow more and more over the next couple of weeks and months and years.